Only a small proportion of individuals who are genetically susceptible to celiac disease actually develop the condition, though the reasons why have been unclear. Now, a new study suggests it may be down to how certain gut bacteria respond to gluten. Celiac disease is an immune disease in which a person is intolerant to gluten, a protein found in grains including rye, wheat and barley. It is estimated that around 1% of the American population has celiac disease. When an individual with celiac disease consumes gluten, the immune system responds by causing damage to the small intestine. This may lead to abdominal pain, diarrhea, bloating and fatigue, among other symptoms. Certain gene mutations are known to trigger celiac disease. However, only 2 to 3% of people who possess such mutations actually develop the condition. Germ-free mice showed signs of celiac disease in response to gluten. The team assessed 3 groups of mice that expressed a gene called DQ8, which is found in humans, and makes them genetically susceptible to gluten intolerance. Fast facts about celiac disease. Around 83% of Americans with celiac disease are undiagnosed or misdiagnosed with other conditions. The only existing treatment for celiac disease is a gluten-free diet. Around 5 to 22% of people with celiac disease have a first-degree relative with the condition. Each group of mice had different gut bacteria compositions, or gut microbiomes. One group was germ-free, while another group was clean-specific pathogen-free SPF. Their gut microbiomes were free of Proteobacteria, a group of gram-negative bacteria, and opportunistic pathogens. The remaining group was made up of conventional SPF mice, which possessed a wide range of gut bacteria, including Proteobacteria and opportunistic pathogens, such as Staphylococcus, Streptococcus and Helicobacter. The researchers exposed each group of mice to gluten. They found that the germ-free mice showed increased levels of intraepithelial lymphocytes in the gut. Proliferation and activation of eels is an early indicator of celiac disease. Increased eel levels, however, were not seen in the clean SPF mice. What is more, the germ-free mice experienced increased death of cells that line the gastrointestinal tract, called enterocytes, alongside anatomical alterations of the small, finger-like projections that line the small intestine, known as the villi. The researchers also identified the development of antibodies in response to a component of gluten, called gliadin, among the germ-free mice, and these mice also demonstrated T-cell responses specific to this component. Interestingly, the team found that development of gluten-induced pathology was halted in the clean SPF mice compared with the germ-free mice, but this was not the case when the clean SPF mice received enteroadherent Escherichia coli from a patient with celiac disease. Increasing Proteobacteria worsen gluten-induced pathology. Conventional SPF mice demonstrated greater gluten-induced pathology than clean SPF mice, according to the researchers, so the team set out to investigate whether the presence of Proteobacteria, such as Escherichia and Helicobacter, plays a role. On increasing the presence of Proteobacteria among conventional SPF mice by administering an antibiotic, called vancomycin around the time of their birth, the researchers found that gluten-induced pathology got worse. Specifically, the team identified an increase in levels of eels. These studies demonstrate that perturbation of early microbial colonization in life, and induction of dysbiosis, characterized by increased Proteobacteria, enhances the severity of gluten-induced responses in mice genetically predisposed to gluten sensitivity, says Dr. Verdu. Importantly, our data argue that the recognized increase in celiac disease prevalence in the general population over the last 50 years could be driven, at least in part, by perturbations in intestinal microbial ecology. Specific microbiota-based therapies may aid in the prevention or treatment of celiac disease in subjects with moderate genetic risk.